on a topic called friction, which is a type of force. We have two kinds of force. We have the contact force and we have the force field. Contact forces are those ones that need contact before they can have influence on something. Example, push. While force field are those ones that they don't need any contact to act on something. If I throw a man out of this building, certainly he will go down, whether something is in contact with it or not. Example of such forces are gravitational force. But now, contact here, friction is an example of contact force. So we'll say that first, friction is a contact force which acts at the boundary surface of two contacts or two bodies in contact, and it tends to oppose the motion of one over another. And we have two types of friction. The first one is what we call the static friction, and the second one is what we call dynamic friction. In explanation, they look so much alike, but they are not the same. First, static friction. If you have a body that is at rest, that is not moving, and you are gradually pushing the body, you will notice that the body will not move immediately until the force you are applying to the body becomes greater than the force holding the body on the ground. Maybe the weight of the body. But once you conquer that force, what happens? The body will move. So we'll say that static friction is that particular force we must overcome for a body at rest to start moving. While dynamic friction, for an illustration, if you are pulling a chair and the chair is not moving while it's still at rest, when the chair moves, it won't move uniformly until at a time when you get yourself, after staggering, pulling it out, it maintains uniformity. So we'll say that dynamic friction is that particular force also that we must overcome for a body that is already in motion to now move with uniform motion. So the first one, the body is still at rest, we overcome it for the body to start moving. While the second one, the body is already moving, but we overcome the force so that the body will now move in uniform motion. From there, we come to mathematical study of friction. The mathematical study of friction. And there are three basic parameters I want us to look at. First is the weight of the body. Secondly, the normal reaction of the body. And finally, the frictional force. Many a times, number one and number two, we misplace them to be the same. No. If a man is sitting on a chair, the man is sitting on that chair with a weight, maybe 80 Newton. Normal reaction is not the same thing as the weight of that man, no. But it's an opposite force acting to the weight of the man, which is also the same 80 Newton. But now it's acting in opposite, that is why we have a balance. If the man is sitting with 80 and the normal reaction is 70, the chair will break and the man will fall. And if the man is sitting with 70 and the normal reaction is 100, that means the man will start going up. But since the weight and the normal reaction, they are the same, when the chair is there without movement, we'll say that there is an equilibrium system. And in such a system, weight and normal reaction, that they are the same. And then frictional force is the next thing I would like to talk about. When a body is at rest, sitting at a place, no movement, the weight and the normal reaction, they are the same. But once there is a movement, there comes a certain force, frictional force, trying to hold the body down from moving. And we say that it opposes the motion of that particular body moving on another body. We bring it down and say that frictional force is proportional to normal reaction. Frictional force is directly proportional to normal reaction. So we'll say that Fr is directly proportional to N, while some textbooks use R. So I would like us to maintain R. Frictional force is directly proportional to R. And for me to remove proportionality sign, which is a dummy sign, to bring an equality sign, then a constant must come in. And this constant is just a natural thing taking care of the surface, whether the surface is rough, whether it's smooth, whether it's watery, whether it's oily. It's that constant that will take care of it. And we call it coefficient of static friction. So we'll say that frictional force, F, is equal to mu R, where mu there is the coefficient of static friction, which shows us or tells us how the surface in which the friction is occurring is, whether it's smooth, rough, oily, watery, or any other thing. Friction on inclined plane. We just said it that when we are on a smooth surface this way, and we have a weight pressing down, there is a normal reaction acting upward. Now if we start carrying this up such that an inclined plane will be produced, because it's up will not show that the weight is still acting vertically downward. The weight is still on the plane pressing vertically downward, and there is an angle created here. And from scalars and vectors, we were showed how we can calculate the vertical component of anything given. And since somewhere here we have the weight, which is mg, and now we are looking for the vertical component, if we can remember, recall that the vertical component then we said is the resultant vector sine theta. Bringing it to this, the resultant vector here is weight, which is mg, and the vertical component here that we are looking for, we now say that weight on inclined plane is equal to mg sine theta. While the normal reaction, which is acting on the horizontal now, is the horizontal component, which is n, which is equal to, or r, which is equal to mg cos theta. Now bringing this to the equation we just finished with, we say that frictional force is equal to mu r. That means that frictional force is equal to mu mg cos theta. While here frictional force, we have mg sine theta. Making that the subject of the formula, we have mg sine theta equal to mu mg cos theta. Making mu the subject of the formula, mu will be equal to mg sine theta all over mg cos theta. Mg will travel with mg and both may go to honeymoon. We have mu equal to sine theta over cos theta is equal to tan theta. So the major formula for coefficient of static friction is tan theta, which from here also we can say, from this particular equation, we can say that mu is equal to frictional force all over normal reaction, which is the same thing down here to be equal to tan theta. This is a basic equation that is very important that you must always remember. That mu is equal to frictional force over normal reaction, and at the same time is also equal to what? Tan theta. But don't forget that at this point in time, this particular body is neither sliding down nor pushing up. It's just at a place. And at that point, we'll say that frictional force is equal to weight on the plane. And that is why here we're using weight, and here we are now able to use friction, because both are the same, because it's neither sliding nor pushing up. But now we'll look at the case when the body is either pushing up or sliding down. Okay, talking about friction on inclined plane, we just finished. On the case we said this body is neither sliding nor going up. And the conclusion there is that frictional force is equal to weight on the plane, which is the same thing as mg sine theta. That case has been settled. But now we want to look at the situation where this particular thing is pushing up. You notice that if this thing is pushing up, the body there is pushing up, there are some forces it must overcome. First, the force that will push this thing up, we call it maybe the force of the pushing or the pushing force, must first overcome the weight of this particular body. That is the first thing. And secondly, it must overcome the frictional force down here, which is making this now to go up. Because if the frictional force has not been overcome, this body cannot go up. So we said that pushing force, or the force that is pushing this up, is equal to the weight which it will overcome first, and the frictional force, which is another thing that it will overcome. Bringing this into mathematics, we'll say that pushing force, Fp, is equal to weight, which is mg sine theta, plus frictional force. From the other formula that I gave you, we'll say that frictional force is mu times normal reaction, which is mu dot r. But I told you that r is the horizontal component, which is mg cos theta. So we'll say that pushing force, Fp, is mg sine theta plus mu mg cos theta. Mg can come out of the bracket so that we have pushing force equal to mg, all bracket, sine theta plus mu cos theta. This formula is very important, most especially for those of you in exam class. They will give you a question like this and say, calculate the total force required for the body to go up the plane. This is what you need to answer that problem. Don't cram it. Once you are here, you can take care of all this. Now, what if the body is sliding down? It's no longer going up, but it's coming down. When it's coming down, something should be on your mind. That is sliding force. It simply means that at that moment, the friction there seems negligible. It's no longer there. It's no longer holding the body. So we'll say that the force of sliding is equal to first the weight on the plane, but instead of plus now when it's going up, what we have is minus frictional force, such that we have F sliding to be equal to, my weight is mg sine theta, minus the frictional force is mu r. While r is mg cos theta, that is the horizontal component here, we'll have fx to be equal to mg sine theta minus mu mg cos theta. Bringing out mg out of the bracket, or factorizing it out, we have mg bracket sine theta minus mu cos theta. This is another important formula that you must take note of. For the question will come in this way. If the body is sliding down the plane, calculate the total force required for the body to slide down the plane. Sometimes also they may say calculate the acceleration instead of force. They will give you the mass. For example, they may tell you this is 80 kg and they say calculate the acceleration. Don't forget that mass is inculcated here as force, because force is equal to mass times acceleration. All you need to do is to rewrite Fx as m times a, which is mass times acceleration equal to mg bracket sine theta minus mu cos theta, so that you can make a the subject of the formula. That means that m will marry m and both will go maybe somewhere for honeymoon. So we have a equal to g bracket sine theta minus mu cos theta, and this is acceleration of the system. The same way you can apply it on the pushing force to calculate your acceleration. The only difference is that in sliding we'll have negative at the center, while in pushing we'll have positive at the center. Okay, in concluding the friction, its definition and description, concluding the types of friction, which I told you about, static and dynamic, which another name for dynamic can be called kinetic. From there we'll move down to the mathematical study of friction. Now, friction on inclined plane, we've been able to talk about when it's at rest, when it's pushing up, and when it's sliding down. And I think that is the basic or the major things we need to know about friction as long as any examination is concerned. And that will push us to the next wonderful topic, which is from the book of conservatives now, no longer in concepts of motion. So we are moving into conservatives with the first topic there, work, energy and power.